Hello.
Hi.
Hello, can you hear me? I'm audible.
Yeah, I can hear you.
Okay. So just begin. Let me know when you can see my screen.
Okay. باكستاني عايش في اليوكي. في ولايات تانية ما في أمريكا لكن في ولايات.
Can you see my screen, Daniel?
Yes.
Okay. Okay, so we'll be doing sequences today. We did discuss the steps of how we are going to approach the sequence problems in the last class. So did you go through the notes again of the last class?
Yes.
Okay. Okay, cool. So just a quick recap. We studied okay, yeah. So we studied that there are three kinds of sequences in our syllabus. You've got your linear sequence, you have got your quadratic sequence, and you have your cubic sequence. And we also discussed that the type of sequence is determined by the level of difference on which the level at which the difference is common. Right, so for example, if you have any sequence A, B, C, D, E, whatever, and you look at the difference between these terms, the first, second, third, fourth, fifth, these terms, if the difference is the same, for example, it is +3 here, +3 here, +3 here, +3 here, then this would be your D1 or your level 1 difference. If it is not the same, if it is like 5 here, then 7, then 9, then 11 maybe, then the difference will actually be the same on the second level. It's +2, +2, +2. In this case, this will be your level 2 or D2. So this first case, level 1, will be your linear sequence. The second case will be a quadratic sequence. And in cases where you have got where the difference is not the same even at the second level, we have to go to the third level. And if the difference is same on the third level, those sequences are basically called your cubic sequences. So are we clear on this?
Yes.
Okay, so this was sort of the background knowledge that we were supposed to have. So now let's start with the linear sequence and do a couple of questions, and then we'll move on to quadratic. So basically, linear sequences are sequences where the first difference is the same. Okay. For example, you have a sequence 1, 5, 9, 13, 17. This is +4. This is +4 again, and +4 and +4. So same difference is on level 1, hence this is a linear sequence. Now, how do we solve? For example, you were being asked if you had this sequence, the same sequence, 1, 5, 1, 5, 9, 13, and 17. So what, and the question, the examiner can ask you many different sort of questions. One question which can be asked is, what will be the next two terms in the sequence? What do you think the next two terms will be, Daniel?
Can I calculate first?
Yeah, sure.
Yeah.
You have to just tell me intuitively what the
Yeah.
next two terms will be. Yeah.
Okay. 21
Okay, good.
and 25.
And 25. And how did you do that exactly?
I added the 4.
The 4, the difference, right?
Yes.
As the sequence is following the same difference of +4, you just added 4 two times and got your next two terms. Okay, good. So 21 and 25. Perfect. Another question which they can ask you is that what is the term to term rule for this sequence? Any idea about this?
What is the term rule?
Yeah, what is the term to term rule for this sequence? Have you heard this before? What is meant by term to term rule? Any idea?
No.
Okay, so it's very basic. The term to term rule is basically what you're doing to one term to get to the other term. Okay,
Okay.
it's very simple. So what are we doing here? We are adding 4, right?
Yes.
In order to get from one term to the other term, we're adding 4. Your answer would simply be adding 4. Okay.
Oh.
Yeah, it's very simple.
I thought it was n plus 4, like when we.
No. That's another thing. We'll get to that. So
Okay.
are we clear so far?
Yeah.
Okay. Now the most complicated question and the most, the highest marks would be for this question would be, the question would be, either they can ask it to you like, what formula would be used to find the nth term? Okay, they can either ask you this, or they can ask the same question can be asked just simply like this: find the nth term for the sequence. Okay.
Yeah.
Okay, so yeah, both of these are the ways in which they can ask the same question. So basically, they're asking you to. Okay, so yeah, for example, also one other way that this question can be asked is, what would be the, well, let's say 19th term in the sequence, right? Now, when it's just plus 4, it's pretty much easy. It's very extremely easy to just do that in your head. But when you're talking about quadratic sequences or cubic sequences, or even complicated linear sequences, in those cases, finding the 19th term would be very hard to do. So basically what you'd have to do in order to get to the 19th term would be to find your n-term formula. Okay, n-term formula. Now let's talk about how we are going to approach these problems, the n-term formula. So when we're talking about linear sequences, because we are doing those for now, you've got two basic steps and you'll have your answer. The first one is that you'd divide the common difference by 1 and multiply by n. Okay, so this would be the first step. And in the second step, what we'd do is add or subtract. We'll either add or subtract to get we can write the first term or basically just any term that would work. Okay, now let's do a few examples. We can actually start by doing that example we did earlier, 1, 5, 9, 13, 17. Okay, we've got this question. Example 1, 5, 9, 13. Are you with me, right? You're with me?
Yeah.
Yeah, cool. So, okay. So this was our question. And okay, the first step that you have to do every single time is that you need to find the difference, and you need to figure out what level the difference is basically on. So for 1 to 5, we've got +4. We have got from 5 to 9 is also +4. Here it is the same, and again it is the same. Hence, this is a level 1 difference, D1. We call this D1. And this would suggest that this is, in fact, a linear sequence. Okay, cool. Now, you look at the rule 1, which is you divide the common difference by 1 and multiply by n. This right here, this is the common difference, +4. Okay? This thing is common difference. This is the common difference, +4. So what you basically need to do is you need to divide 4 by 1. You write 4 divided by 1, and you'll get 4 itself, and then you'll multiply that 4 by n. You'll write the n next to it. So this was your first step. Okay. Now, Dania, what I would highly suggest is that we make a table, which will make it very easy for you when we actually do cubic and quadratic sequences. So the table looks something like this. First of all, you will write n. Here, underneath n. So underneath n, you will write the terms. Then you will write this expression which you just made, right? 4n. 4n. Now, n is very basic. It's just the number of terms, right? So you'll write 1, 2, 3, 4, 5, 6, the number of the term. Second are the terms themselves, which are 1, 5, 9, 13, and 17. You'll write those then. 1, 5, 9, 13, and 17. Are we good so far? Is it clear?
Yeah.
Yeah. And the next line is 4n. See, now basically this first row, n, will be multiplied by 4, and you'll get your answer here. So 4 times 1, which is just 4, then it's 8, then it's 12, 16, and 20. Is it clear?
Yes. So we don't multiply we just multiply by 4, but without the n. Like
No,
normal
no,
multiplication.
basically, no. We are multiplying the n. No? Wait, let me just erase these and we'll write the steps over here as well. Okay, so what we're basically doing here is we're doing 4 times n in this particular column is 1, right?
Yeah.
Got 1. So we'll multiply 4 by 1 to get 4. Okay.
Yes.
Same is the case with 2. We'll multiply 4 by 2 to get 8 and then so on, right? 12, 16 and 20. Is this clear?
Yes.
Cool. And now at the end, what you need to do is basically just subtract this 4n numbers, these 4n numbers from the top numbers, the term numbers. Like 1 minus 4 is minus 3. Okay. 5 minus 8 is also minus 3. 9 minus 12 is minus 3. Minus 3. 13 minus 16 is negative 3. 17 minus 20 is also negative 3. Right? Are we good?
Yes. Yeah.
Cool. Okay, perfect. So basically, once this table is done for linear sequences, you're basically done. Your answer would be this 4n, this expression that you just derived above, 4n, and this particular number placed right next to it, minus 3. This is your n-term formula.
Okay.
Is this clear?
Yes.
Okay. So now to test if you've got this right or wrong, what we'll do is, we'll just, for example, if I ask you, what would be the 4th term in a sequence, who has the n formula, this one, you'll just write 4 times 4 minus 3. 4 times 4 is 16 minus 3, which is 13. We see the 4th term here is 13. Right? So this means that you calculated it correctly. So are we good? Do you understand it? Are you there,
Okay.
Danya? Can you hear me?
Yeah. Yeah.
Oh,
So we
cool.
basically multiply 4 by 4 and then minus it by 3, which we would get 13.
Yeah, so basically, no, you got this formula, right?
Yes.
This formula is for this particular sequence. Okay. Now,
Yeah.
basically, if the examiner asks you what would be the 4th term in the sequence, right? So you can basically just this n is basically the number of term, right? So you're looking for the 4th term. You will replace n with 4, like we did here. 4 times 4 is 16, and then minus 3, you'd get 13.
Yes.
Right, cool. Okay, so now let's do one other example of linear sequences, and then we can move on to quadratic and cubic ones. So let's take this example. The question is 3, and you have maybe 9, 15, 21, 27. Okay, I'll solve it for you, and then or if you want to solve it, you can solve it, and then you can tell me whatever you want.
Okay.
Are you solving it?
Yeah, I'm
The
solving
question
it.
is, you need to find the n term formula. Okay. Yeah, you can just stop looking at the screen and do it, and I'll do it on the screen, and then we can check if you've done it correctly. Okay.
Okay. I'm done.
What is your answer?
6n
Mm-hmm.
minus 5.
Okay, so how'd you get -5? You can look at the table that I made and compare it with your table. So the 6n part is correct. The minus part is correct as well.
I minused 1 by 6 and 2 by 12 and 3 by 18.
No, that's wrong.
Okay.
It's very simple. You look at this 6n, right? You've got 6n here. You must have 6n as well, right?
Yes.
Yeah, right. So basically 6n in this column means n is equal to 1. See, n is equal to 1. So 6 times 1 would be 6. In this column, n is equal to 2. So 6 times 2 would be 12. 10 times
Yeah.
3 would be 18, 24, and 30.
Yes.
And then
That's
you
what
just
I did.
subtract.
Yes.
So once that's done, you just, it's basically, it is just 3 minus 6. You get -3. 9 minus 12, that's -3. Again, all of these like that, you get -3, not -5.
Okay.
Right? So the correct answer for
Yes.
this is 6n minus 3. So good job on the 6n, because that was the complicated part. But next time, please, be very careful about what you're adding and subtracting.
Okay.
Okay, cool. So would you like a few other questions, or can we move on to quadratic sequences now?
We can move on to the quadratic.
Okay, cool. Because I do have many questions, but I was hoping if we could get through this all the sequences in the class, and then you can do the questions at home, and you can let me know if you get confused and if you get stuck.
Maybe add the examples to the homework, so it's like more practice.
Yeah. So those examples, Zanya, I would say that the examples that I will give you. Basically, those examples you can do. You have to do. You definitely need to do those examples which I give to you. But all the chapters that we've done so far, right? All the topics from the numbers from chapter number 1, all the examples you should be able to do, right? In your own time, you can try doing all the other examples which I don't give to you, but they are there, and you can look at the answers in the back, and then you can see if you get confused anywhere, you can let me know. Okay, so I got stuck here, or I didn't understand why the answer was like this, mine was like that, and we can discuss those questions in class.
Okay.
Okay, sound good?
Yeah.
Cool, perfect. Okay, so now let's discuss quadratic sequences. So again, the rules of solving a quadratic sequence would be, so basically these are when the second difference is the same. Okay. And just to give you an example of this, let's say you have this sequence 10, 26, 48, 76. Okay. So in this case, the difference between 10 and 26 is plus 16. Between 26 and 48 is plus 22. Between 48 and 76, it's plus 28. So level 1, it's not, you don't get the common difference on level 1. So now let's get to the level 2, where you've got plus 6 here, and you've also got 22 plus 6 would make 28. So the second difference is the common difference. Hence, this sequence is a quadratic sequence. Clear so far, Maya?
Yes.
Good. Okay. So now how do we go about solving these? The first step would be to divide the common difference by 2 and multiply by n squared, or n raised to the power of 2. So this is the first step that we're going to take. And the second step would be to add, or in fact, let's just add a table here. Second step would be make the n table until we're left with a common difference. And the third would be simply add or subtract to get this first term. Okay. So now let's do a couple of examples for this. For example, this example itself, 10, 26, 48, 76. This is your sequence, 10, 26, 48, and 76. Okay, so the difference, as we understood before, the differences are 16, 22, and 28 on the first level, plus 16 plus 22 plus 28. And then you've got a plus 6 here and the plus 6 here. So as this is on level 2, we already discussed that this would be a quadratic sequence. So the first step would be divide. You divide the common difference by 2, and you multiply that by n squared. So the common difference, which is 6 in our case, plus 6, we'll divide this 6 by 2, and we'll multiply the answer by n squared. So 6 divided by 2 is 2 times 3 is 6. 3 multiplied by n squared, and we'll be left with 3n squared. Okay, so we're done with this term. Now we have to make the n table. Cool. Okay, now let's make the n table. We'll write n here, then we'll write the terms, then we'll write this 3n squared, 3n squared. Okay, now that terms, we have got 4 or 5. Okay, we have 4 terms. We'll write 1, 2, 3, 4. Then we'll write, okay, then we have to write the terms themselves, which are 10, 26, 48, and 76. 10, 26, 48, and 76. And after that, we'll write 3n squared, okay? So 3n squared, when n equals 1, 3n squared would be 3 times 1 squared. 1 squared is just 1, so the answer would be 3. Now, are you with me so far, Danya?
Yes.
Yeah. So for 2, when n is equal to 2, n is equal to 2, 3n squared would be 3 times 2 squared, which would be 3 times 4, which would be 12. Okay. Now,
Okay.
let's say, and then for 3, it would be 9, 9 3s are 27 when you calculate it. And for 4, in fact, just give me 1 second. I think this particular question, we need to do once we're done with the cubic ones. Just give me 1 second. Let me just. Yeah.
Yes.
The time for this particular question would be once we're done with the cubic ones, because there is a concept that we need to understand before we do a sequence like this. But I'll do another example where you get the idea. Okay.
Okay.
So instead of this, let's take this sequence. Okay, so the question you're being asked is, you've got this sequence 4, 7. This is a past paper question, by the way, 4, 7, 12. And this was for, I think, 2 or 3 marks. 4, 7, 12, 19, and 28. Okay. Now, they're asking you to find the nth term. Okay. So this is how they ask you in the exams. In fact, the questions which I will share with you will have this only question and this very question in them as well. Anyway, now let's look at the differences. 4 to 7, it's plus 3. 7 to 12, it's plus 5. 12 to 19 is plus 7, and 19 to 28 is plus 9. So the level 1 differences are not common, so we need to move down another level. So 3 to 5, it's plus 2. 5 to 7 is also plus 2. 7 to 9 is also plus 2. On the second level, we've got a common difference. Hence, we've identified this to be a quadratic sequence. Good so far?
Yes.
Okay, cool. Now, the second step is the same as we did last time. You need to make the end table. Bring this table, let's say here. It's easier to fit in. Yeah, perfect. Okay. So you've got your 4 terms. Oh, in our case, it's 5 now. 5 terms. Okay. The terms are 4, 7, 12, 19, and 28. This is very hard to read. Wait. Just change the paper type. It's still very hard. Okay, I think it's better now. The color is messing up actually. Wait. Yeah, okay. So you've got your numbers, number of terms, you've got your terms. Now we'll move on to, oh, okay, we actually forgot to do the first step here. Lana should have told me that we forgot to do the first step. The first step is you divide, yeah, it's all right. So you divide the common difference by 2, and then you multiply that by n square. This is the common difference. 2 divided by 2 times n squared. This would be 1n squared, or just n squared. Okay. So here you'll have n squared, and now we'll calculate the rest of it. So n squared in this column means 1 squared. 1 squared is just 1 times 1, which is 1. In this column, it means 2 squared. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. And 5 times 5 is 25. Are we good so far?
Yeah.
Yeah. Now we'll just subtract these. So 4 minus 1 is 3. 7 minus 4 is also 3. Then you've got 12 minus 9, which is 3. 19 minus 16 is also 3. And 28 minus 25 is also 3. So your answer for this particular sequence would be n squared, which we found from here. Plus,
minus 3.
No, this time it would be plus.
Okay.
You see, because 4 is greater than 1, right? 4 minus
Yeah.
1
Yes.
would be 3. In the previous question, the term was
Was
less
minus.
than the end term. Right, exactly. So hence we had the negative terms. This time it's a positive answer. And you can check your answer by, you already know the third term, for example, in the sequence. This is your sequence 4, 7, 12, 19, and 28, right? This is the
Yes.
third term, which is 12, right? This is
Yes.
the third term. What you can do is you can simply put this 3 inside this equation. So this would n squared plus 3 would become 3 squared plus 3. So 3 squared is 3 times 3, which is 9, plus 3, which is 12, right? The answer
Yes.
matches. Hence, this is correct.
Yeah, so in each equation, the answer is gonna be different from each
In
equation.
yeah, from each equation, every single equation would be specific to the sequence that you're trying to solve, right?
Yes.
Like this equation is specific to this particular sequence,
Yes.
right? You can never
Yeah.
put any other sequence, any other equation for the sequence. This is the only equation for this particular sequence.
Yeah.
And whenever you put a value, for example, if the examiner asked you what would be the 150th term in the sequence, right? So in that
Yes.
case, you'll just take the square of 150 and then you'll add 3. This would be a very big number. I don't know what that is, but I think it would be 225 something thousand or something. Anyway, you get the gist, right? So you just solve this
Yes.
in your calculator and get them the 100th term. So this is pretty much it about quadratic sequences. I will, however, teach you another way to do the quadratic and cubic sequences, but I wanted you to understand the logic, okay?
Yes.
For cubic sequences, we'll try to follow a different method. And in the next class, you practice your quadratic sequences the way we've discussed in this class. In the next class, I'll teach you another way, okay? Just for quadratic sequences.
Yeah, it's
The
okay.
other two, yeah, the other two are good. Okay, so now, Dania, we start going into a little bit of a complicated realm when it comes to cubic sequences. But the good thing about maths is it's only complicated until you've practiced it enough. Okay, so basically what these are very simple. And the chances of you getting cubic sequences is also pretty low, right?
Yes.
So let's take an example first, and then we'll get to the method. So you've got 4, 14, 40. Then you have 88, and then you'll have 164. Okay. Now you have the differences between 4 and 14 is 10. Then the difference between 14 and 40 is 26. Then you between 40 and 88, it is 48. And then 88 and 64, it is 76. Okay, so this is the first level. Obviously, it's not common, so we'll keep digging more. So between 10 and 26, by the way, these are all plus.
Yes.
Okay. So between 10 and 26, you have
It's 16.
16. 26 and 48, you have 22. And between these two, the difference is plus 28. And as this is still not a common difference, the difference too, so we have to keep digging. Between 16 and 22, the difference is plus 6. And so between 22 and 28, the difference is also plus 6. This is a common difference, so we can stop at D3. As D3 is a common difference, this is a cubic sequence. Are we good so far?
Yes.
Okay, so for cubic sequences, Dania, you have to memorize 2 things. See, previously up until now, you only had to memorize the methods, right? The methods of solving linear or without the steps. You
Yes.
actually, if you memorize the steps, you'll solve the question. But this time you also need to memorize some formulas, right? Formula
Yes.
to
Yeah.
solve the cubic sequence. So now let's talk about this. So the first formula that you need to memorize is this one. Dn equals a times n raised to the power 3 plus b times n raised to the power 2 plus c times n plus d. Okay. The second one is a plus b c plus d is equal d1. Then we have d1, which is equal to 7 times a plus 3 times b plus 6. Then you have d2, which is 12 times a plus 2 times b. And then finally you have d3, which is 6 times a. Okay, this may look a little bit complicated right now, but there is no other method. The other method, if we actually start doing it the way we did linear and quadratic functions, some of the questions might take you like 5 sheets of working. So there is no point in doing it that way. It's better to memorize just the formulas. So, okay. So now let's talk about what these different terms actually mean. So where is our sequence? I'll just copy this. Paste this here. Okay, so are you with me, Tanya? You're here?
Yes.
Okay. So now let's talk about what a few of these terms mean. So once you have made this particular, once you've decided and you've built this particular table, you can call it or whatever, where you need to focus is just these first 4 numbers, okay? You need to focus on this 4, this plus 10, this plus 16, and this plus 6. Now, this 4 is your D1. This plus 10 is
D2.
your, no, it's D1.
Okay.
This plus 16 is your D2. And this last common difference is your D3.
Okay.
Okay, are we good?
Yeah. Yes.
Okay, so now you basically just have to plug values into the equations and solve them. Now it's very simple. So the first equation is extremely simple. We start from the bottom and you work your way up. Okay. So the last equation that we have is this: D3 equals 6a. Okay. So we'll take this D3. Or instead of complicating it, you can just write 1, 2, 3 like this. Simple 1, 2, 3 because it's weird. D1, D1, D2, D3. Okay, so you start from this. D3 is equal to 6a. Now, the value of D3 is 6, right? We just discussed. So you just plug in 6 here. Is equal to 6 times a. You'll divide by 6 on both sides. 6 by 6 is equal to 6a by 6. This will be cancelled. and you will have A equals 1. Are we good so far?
Yes.
Yeah, it's pretty simple. It's just plugging equations. So once
Yeah,
you have
very
A, now you move on to the second equation, which is D2 is equal to 12A plus 2B. So you'll write D2 equals 12A plus 2B. Now your D2, again, you have your D2, which is 16. Then add 16 here equals 12 times A. You just found A here, which is 1. 12 times 1 plus 2B. Now this will become 16 equals 12 plus 2B. This 12 will be moved here. It will become 16. Here it is plus 12. Over there it will be minus 12. 16 minus 12 is equal to 2B. You'll get 4 here is equal to 2B. You will divide by 2 on both sides. You'll get 2 equals to B, or B equals to 2. You get this, right?
yes.
Yeah. Okay. So we've got the value of A, the B. Now we need a value of C. You'll move on to the next equation, which is this one. 7A plus 3B plus C. So you will write D1 equals 7A plus 3B plus C. D1, we have 10. So we'll take 10 equals 7 times A was 1 plus 3 times B was 2 plus C. So you get a 7 plus 6 plus C, 10. And you get a 10 is equal to 7 plus 6 is 13 plus C. And then you subtract 13 from both sides. You get a negative 3 is equal to C, or C is equal to negative 3. Is this clear as well?
Yes.
Cool. And now we move on to the last equation, which is the simplest of all those, or in fact, not the simplest, because the first one is also extremely simple. The last equation is this one. T1 is equal to A plus B plus C plus D. So write this here, T1 is equal to A plus B plus C plus D. Now we get to what T1 was. Where is it here? So this was T1, which is 4. We'll write 4 here. Then A was 1, B was 2, plus C was minus 3, plus D. We're basically trying to find the value of T from this equation. So you will have 4 is equal to 1 plus 2, which is 3. This plus and minus will be multiplied to become minus. 3 minus 3 plus D. 3 minus 3 is 0. So 4 is equal to 0 plus D, which means that D is equal to 4. So are we good till here?
Yes.
Okay. And the last thing is this equation, an squared, bn, an cubed, tn is equal to an cubed, bn squared, cn plus d. So we'll write this by tn equals to an cubed plus bn squared plus cn plus d. We'll just put in the values of a plus b, a, b, c, and d. So for us, a was 1, so 1 n cubed, plus b was 2, 2n squared. C was minus 3, so or plus minus 3 times n, and then D was 4. We'll simplify this. This 1n cubed can be written as n cubed only, plus 2n squared. This plus and minus will become minus 3n plus 4. And this is your answer.
Okay.
So you got it, right?
Yes.
Yeah, it is a little bit of work because you need to memorize these. But this is something that you'll have to do in order to nail this question.
Okay.
Okay, so now let's just get a very quick check on whether we've calculated this correctly. Our sequence was 4, 14, 40, then 88, then 64. This is the first term, the second, third, fourth, fifth. So the fifth term. We'll try to find the fifth term. Okay. So we'll plug in 5 in the places of n. You get 5 cubed plus 2 times 5 squared minus 3 times 9 plus 4. Did you say something, Nana? Hello?
Yeah.
Yeah, do you say something? Do you have a question?
No, I don't have a question.
Okay. Okay. So when you solve this 5 times 5 cubed is basically just 5 times 5 times 5, and this would be 125, plus this is basically 2 times 25, because 5 times 5 is 25, times 2 would be 50, minus 3 times 5 is 15, plus 4. And when we simplify this, we get 175 plus 4 minus 15. So this becomes 164. Okay, and our fifth term was, where is it? Yes, 164. And our fifth term was 164. So that means this equation is correct. So is this clear now? The
Yes.
question, the examples, and the way we check this. Okay.
Yes.
Perfect. Let me try to find one more question which we can do. Okay, so this is a very basic linear question. I'll try doing this. I'll try to find you a few cubic questions which you can try at home. You have
Okay.
a question which is -25, 18, 11, 4, and -3. Okay, so these are the first 5 terms of the sequence. Find the n term of the sequence. So 25 to 18, it's -7. Again, 18 to 11, it's -7 again. Here it is -7. 4 to -3 is also -7. So the difference is at level 1, which means this is a linear sequence. Okay, so the first thing that we'll do is we'll take this common difference. -7, we'll divide it by 1 and multiply it by n. We get -7n. Now we'll move on to the n table. We will write the values of n first. 2, 3. How many values are there? 1, 2, 3, 4, 5. So we'll have 1, 2, 3, 4, and 5. After the values of n, we have to write the terms which were in the sequence, which are 25, 18, 11, 4, and -3, 25, 18, 11, 4, and -3. And now we'll use this term, -7n, and we'll find, so -7 times 1 would be -7 itself, then -7 times 2 would be -14, then -7 times, or in fact, as this is a linear progression, what we can basically do here is, you've got to see, okay, so when you're doing linear progressions, what you can do is you can basically just see, okay, so you have these two numbers, -7, and then you have 25. So what do we need to do to -7 to get to 25? For example, if it was -7 and we had to get to just 5, so we'll basically had to add 12, right? -7 plus 12 would be 5. Does that make sense?
Yes.
-7, and we had to get to 10, so we'd had to add plus 17 to get to 10. Now, in order to get to 25, we'll have to add plus 32. Okay, so you'll just take this 32 because obviously the first term is 25. So your answer would now become negative 7n, negative 7n plus 32. Does this make sense?
Yes.
Yeah, you don't always have to go through the whole table. You can just, when you're talking about linear progressions or linear sequences or progressions. Yeah, one other thing, sequences can also be called progressions. But I don't think I've seen that happen in the IGCSE exam ever. But if you ever come across this, do remember that progressions is just simply sequences. Okay.
Okay.
Okay, cool. So this is pretty much it from my side, Dani. If you have any questions, we're done with all the sequences. I'll just try to go through the other way of solving the quadratic equation, the quadratic sequences, and we'll do that in the next class. But for now, you should be good to attempt any question from the book or from the past papers. I will share try to share more than a couple of questions from past papers with you, which you can do at home.
Okay.
Okay, so any questions, any confusions, can we wrap up?
No, I don't have any questions.
Cool. Okay, so thanks, Dania, for joining. I'll share the questions with you in the morning. I'll try to share them as early as possible, and see you next week.
Okay, thank you, Mr. Ba.
Yeah, bye-bye.